Hello guys, we are going to take a look at the law of cosine. In class you are able to discover the standard form of law of cosine. This will be the form that will be given to you on the final exam. Here on the notes we also have an alternative form given. Note that in this form your equation is in terms of cosine of an angle. Keep in mind that you can always come up with the alternative form of the equation simply by solving for cosine of A. We're going to take a look at 3 examples that are pretty straightforward, and then in class tomorrow we will be completing more real-world applications. So in the first example, we are to find the 3 angles of a triangle with given side lengths of A equals 9, B equals 12, and C equals 14. Although it's not required, I highly recommend that you always get started with a little sketch. It helps you to visualize exactly what you are given. Trying to keep the sides somewhat proportional to what we are given. So if you take a look at this, we have A, B, and C, where side A is 9, side B is 12, and then side C is 14. We certainly did not need the sketch. You can simply go ahead and apply everything in either the standard or alternative form of the equation. Now here we're looking for all 3 angles. It does not make any difference which angle you choose to get started with. A comes first, so I'm going to go ahead and calculate angle A first. To do that, we can go ahead and directly use the alternative form of our equation. Using the alternative form of the equation, we can solve for the cosine of angle A by substituting the values for side B, side C, and side A in our equation. We get cosine of A is equal to 12 squared plus 14 squared minus 9 squared divided by 2 times 12 times 14. You can certainly plug this whole equation in the calculator. When you do so, please make sure that your full numerator is in parentheses, and then you do divided by the denominator also in parentheses. When I did this in the calculator, I got that the cosine of A is equal to 0.7708. Now that I know the value for the cosine of A, I can find actual angle A by using cosine inverse. Angle A is equal to the cosine inverse of 0.7708. When you do so in the calculator, you get an answer of 39.57 degrees. I've mentioned that in class. Please make sure that instead of using this truncated decimal representation of the cosine, you actually do cosine inverse of your answer on the calculator. This will give you the more precise result. So now we have found that angle A is 39.57. I can add that to my sketch, 39.57 degrees, right here for angle A. Now I need to find angle B. Well, to do so, once again, I can go ahead and apply the law of cosine. At this point, however, I have a choice. I don't have to use the law of cosine. Now I know one angle and I know all 3 sides. I can switch and use law of sine as well. I'm going to apply the law of cosine one more time for just now. Next, let's go ahead and find angle B. For angle B, we get that the cosine of angle B is equal to, and we're going to replace each of the sides A, C, and B in the formula for cosine of B. So cosine of b is equal to 9 squared plus 14 squared minus 12 squared, and that is divided by 2 times 9 times 14. Once again, we can use the calculator to input that whole expression. The numerator should be in parentheses, divided by the denominator also in parentheses. The answer for that from the calculator is 0.5278. If the cosine of an angle is equal to 0.5278, then the angle is equal to the inverse cosine of that answer. 5278. Cosine inverse of 5278 is equal to 58.14 degrees. Now we have found angle B as well. This is 58.14. I wish my triangle was a little bit bigger, but this will do for now. Now we have one missing angle. Should we use the law of cosine again? We certainly can, but I think there might be an easier way to find that angle C. You know that angle C is equal to 180 degrees minus angle A minus angle B. We already know angle A and angle B, so we can do 180 degrees minus 39.57 minus 58.14, which one of those are degrees, is equal to 82.29 degrees. And we have found all the possible, or all the angles in that triangle. Okay, let's take a look at the next example. In example 2, it says, for the triangle ABC, angle A is equal to 75 degrees, side B is 12, and side C is 10. Find the remaining angles and side. Well, first of all, let's take a look at which case we're in. For this example, I highly recommend that you definitely sketch your triangle. Angle A is 75 degrees. So let's go ahead and label A, B, C is up here. We're given angle A, 75. And then we're also given side B is 12, side C is 10. Now, let's take a look and think, which case are we in? What is it that we are given? It looks like we're given side, angle, side. We don't necessarily have to look at that from left to right. You're just looking at them in order. So you can think of it as 10, 75 degrees, 12. This is still side, angle, side. You're given two sides and an angle that is located in between these two sides. Whenever you're given two sides and an angle in between, this is our case of side, angle, side, we can always apply the law of cosine. We're looking for the third side, and then we can find the other two angles as well. Well, to find the third side, in this case we're looking for A, we can go ahead and use law of cosine. A squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of the given angle. We can calculate this. I'm going to start my calculator here in just a second. Okay, so let's go ahead and put that in the calculator. 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 75. I already made sure that my calculator is in degree mode, and that gives me an answer of 181.88. Now keep in mind that this answer is for a squared. So a squared is equal to 181.88. Well, in that case, to find a, that is the square root of my answer. On the calculator, I would do square root, so second x squared, the square root of second negative gives me the square root of the answer, and I get 13.486. I'm going to go ahead and round that. A is equal to 13.5. So we have now found this other side is 13.5. Next, I need to find the other two angles. As I said previously, you can use the law of cosine, but you don't have to. So what I would like to do instead is to find angle C. I'm going to use law of sine. 13.5 over the sine of 75 is equal to 10 over the sine of C. When I do this, I can calculate the sine of C by cross multiplying. The sine of C is equal to 10 times the sine of 75 divided by 13.5. When you put this in the calculator, it is 0.7155. Now this gave me the sine of C, but I just need actual angle C. Angle C is equal to the sine inverse of my answer, and that is approximately 46 degrees. So angle C, I have found now, is 46 degrees. Last, I need to find angle B. Angle B is equal to 180 degrees minus angle A minus angle C. Angle B is equal to 59 degrees. And we are all done. We have found all the missing particles. Now the last application for law of cosine, similarly to the law of sine, we can use these rules to find the area of any given triangle. Here, the area formula is the square root of the product C or S times S minus A, S minus B, S minus C, where C is A plus B plus C over 2. I like to think of this as the perimeter over 2. It is half of the perimeter. So let's take a look at how we can apply this. We are to find the area of a triangle with side lengths 11 feet, 16 feet, and 24 feet. Our step number 1 is to calculate how much is half of the perimeter. S is equal to 11 plus 16 plus 24 divided by 2. That is 25.5. And then our next step is to calculate the area. The area is the square root of half the perimeter, 25.5, times half the perimeter minus each one of the sides. So 25 0.5 minus 11 times 25.5 minus 16 times 25.5 minus 24. Certainly you can put the whole expression in your calculator. Please be very careful with the parentheses if your calculator uses those. But the answer that I got was 72.59, or approximately 73, let's not forget the units, feet squared. So that'll be our final answer. Thank you guys, and we're going to do more real world applications in class.